You have just had a long, really exhausting day.
Oh, I know that exact feeling.
Right. You open up an app like Swiggy on your phone, and you spend, I don't know, 20 minutes carefully curating the absolute perfect food order.
You got the appetizers, the main course, everything.
Exactly. And then you hit pay, and the app just crashes.
Oh no, the worst.
The absolute worst. Your screen freezes completely. And then a moment later, you get a text message from your bank saying your money was deducted.
But the app reset?
Yeah. The app completely reset. Your food was never actually ordered. So now you're left hungry, you're angry, and you're out of pocket.
And you have to call customer service, which is a whole other nightmare?
Exactly. And that moment, that absolute moment of panic, that is exactly why today's deep dive is so crucial for you to hear.
It really is a remarkably universal experience, isn't it? I mean, pretty much everyone listening has dealt with that. And it perfectly illustrates the silent, often totally invisible chaos that's happening right behind the screens of the apps we rely on every single day.
Yeah, because we tend to think of a bug as just a minor inconvenience, right? Like a crashing food delivery app.
Right, but when you scale that up to massive enterprise systems, I mean, we're talking banking infrastructure, hospital management software, airline flight routing.
Oh, wow. Yeah. Well, that's a whole different level.
Exactly. At that scale, a single unhandled bug can cause millions of dollars in losses or, even endanger lives.
So our mission today is to explore that hidden ecosystem, the world of software automation testing. We are looking at how software goes from being a fragile, unpredictable mess to the seamless, reliable experience you and I expect.
It's a huge journey.
It is. And to guide this deep dive, we're drawing on a really comprehensive set of frameworks and demo architectures from Lokesh Kumar at LK Cloud Tech.
He's an IT expert who specializes in deconstructing complex enterprise tech, right?
Exactly. So we're going to unpack the underlying architecture of software lifecycles and then zoom in on a specific, really revolutionary zero-code tool called Tosca that is actively upending the tech job market right now.
I think the best place to start, really, is by looking at the overarching blueprint. Because enterprise companies, they don't just write a bunch of code, push it to a production server, and cross their fingers.
Well, you'd hope not.
Hey, yeah. They follow a highly structured framework called the SDLC, which stands for the Software Development Lifecycle.
Right. And historically, people have used the analogy of building a house to explain the SDLC. Like, you plan the budget, draw the blueprint, lay the foundation, build the walls, and then hand over the keys.
That's the classic textbook explanation, yeah.
But frankly, for modern enterprise software, that analogy always feels a bit too static to me.
How so?
Well, building software at scale is less like building a house in an empty lot. And it's more like, well, designing and deploying a high-speed rail network while the trains are already running.
Oh, that's a great way to put it.
Right, because you have to plan the routes, lay the tracks, and test the signaling systems without actually derailing the entire network that's currently operating.
That is a much more accurate way to look at it, especially when you consider how incredibly dynamic the process is today.
Yeah.
The SDLC, it basically moves through planning, requirement analysis, design, implementation, testing, deployment, and finally, maintenance.
But wait, if you look at that pipeline, testing is basically just step 5, right? Like, does a single step really need its own entire deep dive today?
Well, that right there is a massive trap that a lot of people outside the industry fall into. They think, okay, you write the code, and then you test the code.
Which seems logical.
It does, but you can't test what hasn't been built, obviously. But if you wait until the developers are completely finished coding to even start thinking about your testing strategy,
You're in trench.
you are already months behind schedule. It's a disaster. And that is exactly why testing operates as its own entirely parallel universe.
Parallel universe.
Yeah, it's not just a phase. It is an entire shadow organization running concurrently with development. And that's known as the STLC, the Software Testing Lifecycle.
So it's basically a child process living inside the parent SDLC.
Exactly. The STLC spins up its own requirements analysis, test planning, and test case development while the developers are still writing their very first lines of code.
Wow, that early.
Oh, yeah. They are designing the stress tests and hunting for edge cases in the architecture long before there's even a graphical interface to interact with.
Okay, so having that robust SDLC running in parallel is clearly essential. But here is where we hit the real bottleneck in the industry. It's not just about when you test, it's about how you physically execute those tests.
Right, the actual mechanical execution.
Yeah, and for a long time, the industry standard was just manual testing, which intuitively makes sense. You know, human beings sit down and try to break the software using their own human intuition.
And to be fair, human intuition is fantastic for exploratory testing, like finding those weird, totally unpredictable ways a user might interact with an application.
Like mashing the pay button 5 times because the Wi-Fi is slow.
Exactly. But manual testing becomes an absolute nightmare when it comes to regression testing.
Regression testing, let's define that real quick.
Sure. So regression testing is checking to make sure that the new code a developer just wrote didn't accidentally break the old code that was working perfectly fine yesterday.
Oh man, so imagine you are physically opening Amazon.com. You click login, you type your email, you'd have a password, you add an item to your cart, and you log out.
Simple enough.
Right. But now imagine doing that exact sequence 500 times a day.
Yeah.
Every single time a developer changes even one line of back-end code. It's totally unscalable.
It is entirely unscalable. I mean, human beings are just not built for that level of mechanical repetition. We get fatigued, our attention drifts.
Yeah, you get bored.
Exactly. And after 6 hours of clicking the exact same buttons, a human tester is basically guaranteed to miss a subtle UI bug.
But paying a massive team of humans to do highly repetitive, really slow work, it completely destroys a project's budget.
And delays deployment by weeks, probably. Absolutely. Which inevitably led the industry to automation testing.
Right. You use a software tool to basically act as a digital robot.
Yeah.
So it runs that 500-step test perfectly in 30 minutes, while the human engineering team just grabs a coffee.
That's the dream, yes.
But traditional automation introduced its own massive headache, didn't it?
Yeah.
Like tools like Selenium are industry standards. They're free, they're super powerful, but they strictly demand that you know how to code in languages like Java or Python.
Yeah, or you look at a tool like UFT, which is this really expensive enterprise tool, but it still requires deep knowledge of VB
Right.
or RFT, which needs Cucumber and Java.
Yeah.
The traditional automation landscape demanded heavy programming expertise.
It reminds me of a dishwasher, actually.
Okay, I like this. Tell me.
So manual testing is like washing a massive mountain of dishes by hand, right?
Right.
It takes forever.
Yeah.
So automation is the dishwasher. It's supposed to save you. But if you're using traditional code-heavy automation tools, it's like needing a master's degree in electrical engineering just to turn the dishwasher on.
That is a perfect analogy. You had these brilliant QA testers who were amazing at finding bugs, but they didn't know Java.
And on the flip side, you had developers who knew Java inside and out, but they didn't want to spend their highly paid hours writing repetitive test scripts.
Exactly. It created a severe talent bottleneck across the whole tech world. And that bottleneck is exactly what paved the way for the paradigm shift we are seeing right now with Praesentis Tosca.
Tosca. Okay, let's get into this.
So Tosca approaches the problem from a completely different angle. It is a scriptless or zero-code automation tool.
Okay, I have to push back here for a second.
Go for it.
Because as someone who follows enterprise tech pretty closely, whenever I hear the phrase zero code or no code, my immediate assumption is that it's just a marketing buzzword.
Yeah, that's fair.
Usually zero code just means you get a pretty drag and drop interface, but you completely surrender all granular control over what the tool is actually doing under the hood. Does a zero code tool actually hold up against complex enterprise architectures?
That is a very valid skepticism. And honestly, in a lot of low-code platforms, you do sacrifice depth for convenience. But Tosca actually bypasses that limitation using something called model-based test automation, or MBTA.
MBTA, how does that work?
Well, instead of generating hidden scripts in the background that you can't access, Tosca builds a technical model of the application's interface.
Okay.
Think of a robotic arm in an automotive factory. You don't sit down and write 1,000 lines of code telling the arm exactly how to move its individual joints.
No, that would take forever.
Right. You physically guide the arm through the welding motion once, it builds a spatial model of that action, and then it can repeat that exact weld perfectly on 10,000 car doors without any coding.
Oh, that makes a lot of sense. You're modeling the behavior rather than scripting the commands.
Exactly.
And the sheer breadth of what it can model is kind of wild. Because unlike Selenium, which is strictly built for web browsers,
Just web browsers, yeah.
Tosca supports over 250 different application technologies. We are talking web, desktop, SAP, Salesforce, API integrations, mobile environments.
It's massive. And for a huge corporation, that means you don't need 5 different automation tools for 5 different departments. You can just centralize everything.
That's huge.
It really is. And crucially, it integrates seamlessly into modern CI/CD pipelines, continuous integration and continuous deployment.
Right, so the moment a developer commits a new piece of code to the repository, the pipeline can automatically trigger Tosca to wake up, execute a massive suite of regression tests across the entire ecosystem, and just report back in minutes.
Without a human doing anything.
So let's pop the hood and look at how this actually functions, because the mechanism itself is fascinating. The central workspace where you orchestrate all of this is called Tosca Commander, right?
Yeah, Tosca Commander operates essentially as the dashboard of your entire testing infrastructure. It is where you manage the architecture of your project. And inside that environment, the fundamental concept you have to master is the separation of concerns between 2 key elements, modules and test cases.
The distinction between modules and test cases is brilliant. I like to think of it like the master address book for an Amazon delivery driver.
Let's hear it.
So the delivery driver doesn't memorize the exact GPS coordinates of every single house in the city, right? They just have a dynamic address book. In Tosca, modules basically act as that address book.
Exactly.
They store the exact technical location. So the HTML tags, the IDs, the CSS selectors of every button, text box, and drop-down menu in the application.
And by separating that technical mapping from the actual test logic, you create an incredibly resilient system. Tosca actually comes with standard modules pre-built right out of the box.
Like what kind of things?
Things that handle universal actions that don't really change. Things like open URL, maximize browser, or even manipulating standard math functions.
But the real power comes from the user-defined modules. These are the custom mappings you create by scanning your specific application. So you point Tosca at the login button on your company's website. Tosca scans the document object model, the DOM, which is the underlying code of the page, finds the unique technical properties of that specific button, and saves it as a module.
Exactly. And this brings us back to your earlier point about whether zero code means losing control.
Right, my skepticism.
Yeah, you aren't losing control here. You are just abstracting the UI layer from the test logic. Think of it like this. If the test case is the recipe you are trying to cook, the module is the exact grocery store aisle where your specific ingredient is located.
Right. So I write a test case that says, go to the website, click login, enter password. That is the recipe. It references the modules to know where those buttons are physically located in the code.
You've got it.
And here's why that separation is just genius to me.
Yeah.
If a front-end developer decides to completely redesign the website,
Which happens all the time.
and they move the login button from the top right of the screen to the bottom left, my recipe breaks. Because the ingredient moved to a new aisle.
Exactly. And in traditional coded automation, like a massive Selenium framework, a UI change like that might require a highly paid engineer to hunt down and manually update the locator strategy in 50 different test scripts.
That sounds like a complete maintenance nightmare.
It is, but in Tosca, you just open that one specific module, rescan the new button location, and hit save.
Wow.
That's it. Every single test case, every recipe that uses that module automatically updates because they are all referencing that one single source of truth. The maintenance overhead drops so dramatically.
Let's ground this in a practical scenario so you can really picture it. We can walk through the mechanics of a real-world automation flow, specifically automating an Amazon login sequence, to see how Tosca handles both the standard execution and the inevitable chaos of dynamic web environments.
Let's do it. So inside Tosca Commander, you create a new test case. You start by dragging in a standard module for open URL, and you feed it the value, say, amazon.in.
And Tosca doesn't even need you to configure browser-specific drivers like you do in Selenium. It just utilizes the system's default browser architecture to launch the page.
Exactly. It's very streamlined. But once the URL is triggered, you hit your first major hurdle in literally any automation script. Wait times.
Oh, right. Because applications do not load instantly.
Never. And if your automation tool tries to click a button before the server has actually rendered it on the screen, the test just fails.
And when you're building an automated flow, relying on static wait times, like telling the script to rigidly pause for 2,000 milliseconds, that always feels like a total trap to me.
It is a trap.
Because if the server's experiencing high traffic that day, and it takes 3 seconds to load, the 2-second wait fails. But if the server is lightning fast, you're just sitting there wasting time staring at a loaded screen.
That is precisely why relying on hard-coded static waits, like Tosca's T-Box wait module, is generally discouraged for complex enterprise flows. except for maybe some very specific edge cases.
So what's the alternative?
Robust automation transitions to dynamic synchronization. You basically want the tool to pull the DOM, constantly checking the state of a specific element, and the absolute millisecond that element state changes to true or visible, the tool proceeds.
It optimizes the execution time perfectly.
Yes. So, assuming the page is fully loaded dynamically, you use your user-defined modules, you scan the Amazon homepage for the hello sign-in element, you drag that module into your test case, and you define the action as a simple click.
Then you enter the email, then the password, and wait, a vital security mechanism kicks in here, doesn't it?
Oh yes, Tosca automatically recognizes password fields and encrypts the data string.
That's so smart.
The moment you type a password into the test case parameters, it hashes it, ensuring plain text credentials aren't just sitting in your test repository for anyone to read.
So you click sign in, the system authenticates you, and now you want to log out to complete the cycle. In a perfect theoretical world, you just scan the sign out button, tell Tosca to click it, and you're done.
In a perfect world, sure.
But real-world applications are totally chaotic. The code is messy. And this leads us to what we can call the two-sign-out problem.
This is such a classic issue.
I found this part of the architecture deeply fascinating. Visually, as a human user, you look at the Amazon interface and you see exactly one sign-out button.
Right.
But Tosca isn't looking at your monitor. It's reading the raw HTML code underneath everything. And Amazon, like a lot of responsive websites, actually has two sign-out buttons hidden in its code.
Yep. One is formatted for the desktop layout, and one is hidden, just waiting to be used if the screen shrinks to a mobile layout.
And Tosca sees both of them. It realizes they have identical names, throws a multiple controls found error, and just completely halts the test because it doesn't know which one you want.
It is a classic ambiguity problem. If a tool requires unique identification, how do you differentiate two technically identical elements without writing custom code?
Right, how do you do it zero code?
Tosca provides a tiered approach to solving this visually. The most robust method is property filtering.
Let's break down how property filtering actually works mechanically for the listener.
Sure. So you open the properties of both sign-out buttons side by side in Tosca. While their text labels are identical, their underlying HTML attributes will always have slight variations based on their CSS styling or container tags.
Okay.
You scan through those properties. Perhaps one has a visibility tag set to true and the mobile one is set to false, or their parent container IDs differ. You select that one unique property and tell Tosca, filter out any button that doesn't share this exact property.
So you force uniqueness.
Exactly.
But wait, what if the developers were just incredibly lazy and the properties are completely 100% identical at the code level?
Then you move to the second tier, which is indexing. You simply tell Tosca's logic engine, okay, I acknowledge there are two identical elements in the DOM. I want you to just interact with the second one you find in the HTML tree.
Simple.
Very. And if the index is dynamically shifting, you can even use an explicit name parameter to forcefully bind the module to a specific instance.
But the two sign-out problem isn't the only chaos you run into here. Because the sign-out button on Amazon isn't just sitting visibly on the page. It's actually hidden inside a drop-down menu.
Right.
To even reveal it, a user has to hover their physical mouse cursor over the account and lists text. This introduces the mouse over zigzag issue.
Physical mouse automation is inherently unstable. If an OS notification pops up on your screen, or the graphics rendering engine stutters for a frame, or the robotic cursor zigzags even slightly off the hover target,
the drop-down menu instantly collapses before the tool can click Sign Out.
Exactly. You are basically inheriting all the physical unreliability of a human interface.
Which is why the X method is such a game changer. Because instead of telling Tosca to physically drag a digital mouse cursor across the screen, coordinates mimicking human behavior but totally risking failure, you change the action type to the X method.
I love the X method. It completely bypasses the graphical rendering layer. It goes straight into the document object model. It identifies the exact node in the HTML tree that represents that drop-down trigger, and it just fires a JavaScript event directly at it.
So instead of trying to physically move a robotic finger to push a button on a monitor, the X method just hotwires the button directly at the code level.
Yes, hot wiring is the perfect word for it.
It injects the command straight into the architecture, completely eliminating the variable of UI rendering lag. That is just an elegant piece of engineering.
It is highly stable, and it's exactly the kind of sophisticated zero-code problem solving that makes this tool so disruptive in the industry right now.
Yeah.
And if we zoom out from the technical weeds for a second and connect this to the macro landscape, this technology isn't just about making testing easier for a few engineers. It is actively rewriting the operational budgets of major tech firms and shifting the career trajectories of literally thousands of workers.
Let's talk about that market trend. Because the enterprise migration from traditional frameworks like Selenium over to model-based platforms like Tosca is massive right now.
Oh, it's a gold rush.
And it always comes down to the bottom line, doesn't it? Cost and efficiency.
Always. The operational ROI is stark. If you are standing up a complex Selenium automation project, you might need an entire squad of 8 to 10 highly specialized SDETs.
Software development engineers and test.
Right, and they command premium salaries because they are fluent in Java. But a Tosca project, utilizing that centralized module architecture we just discussed, only needs 4 to 5 testers to achieve the exact same operational coverage.
You are looking at a 50% reduction in team size.
Easily.
And beyond just the headcount, you're slashing the time to value. You don't have to spend a full month building a fragile custom coding framework from scratch before you can run your first test. The time it takes to execute your first automated regression test drops from weeks to mere hours.
And that speed translates directly into faster product releases for the company, which means faster revenue.
And that efficiency is translating into very real career mobility, isn't it?
Yeah.
The metrics coming out of the Indian IT sector, for example, are highly indicative of global trends here.
Oh, for sure.
An entry-level Tosca engineer with less than a year of experience is seeing packages around 4 to 6 lakhs per annum. But because the tool is so heavily adopted at the enterprise level, the ceiling is incredibly high.
Right, an automation architect with maybe 5 years of experience, someone who is designing these overarching modular frameworks, they can command anywhere from 22 to 35 lakhs per annum.
That's incredible growth.
Yeah.
And the most profound takeaway here, I think, is who is actually filling these roles. Because Tosca entirely removes the programming language barrier. It basically shatters the traditional gatekeeping of the IT industry.
It really does. You no longer need a 4-year computer science degree to be an automation engineer.
Right. People from totally non-IT backgrounds, arts, commerce, pure sciences, they are successfully transitioning into these lucrative tech roles. Because if you understand the logical flow of how software should work, you can master the tool's modular architecture in a matter of months.
It is a remarkable democratization of software engineering. We've really watched a rapid evolution in this space over the last decade.
Yeah.
We went from humans manually clicking buttons and logging bugs on spreadsheets to humans writing thousands of lines of Java just to click those buttons, to humans architecting visual models to interact directly with the DOM.
Which begs a really, really fascinating question about where we go next. I mean, if we recap the journey today, we looked at the sheer panic of an app crashing and how companies deploy the SDLC and the STLC to catch those critical failures early.
Right.
We saw how the bottleneck of manual testing forced the industry toward automation and how traditional code-heavy automation basically created its own bottleneck.
The dishwasher problem.
Yeah, exactly. And that paved the way for Tosca's model-based test automation. Using Commander to map the DOM with modules, separating the technical locators from the test case recipes, and utilizing tools like property filtering and the X method to bypass the chaos of the UI entirely.
It is a highly optimized system, but as tools like Tosca increasingly remove the need to write code, and as we see newer versions integrating advanced AI that can, dynamically heal broken modules or even predict where a bug might occur based on historical code commit.
Which gets kind of scary.
It does, because what is the future role of the human being in this loop?
Right. If the machine is doing the checking and the machine is writing the tests, does the human tester become obsolete?
I don't think they become obsolete. I actually think the role elevates. They stop being software checkers entirely. I think their real job in the future will be to become, essentially, software psychologists.
Software psychologists.
Or chaos engineers. Professionals whose sole purpose is to understand human irrationality, because the AI can perfectly check if the code functions properly when used correctly. The human's job will be to dream up the unpredictable, highly emotional, completely illogical ways a human being might try to break a system and then force the AI to account for it.
A software psychologist. I absolutely love that framing. Just thinking of all the weird, totally irrational things a panicked, hungry person might do to a food delivery app when their order is 30 minutes late.
Mashing the buttons, swiping randomly.
Exactly. The machine ensures the tracks are laid correctly, but the human ensures the train survives the passenger.
Perfectly said.
So, next time your app crashes while you're trying to order dinner, just remember, somewhere out there, a tester is probably architecting a new modular framework to inject a fix directly into the DOM, making sure it never happens to you again. Keep exploring the architecture around you, and we'll catch you on the next deep dive. On just the headcount, you're slashing the time to value. You don't have to spend a full month building a fragile custom coding framework from scratch before you can run your first test. The time it takes to execute your first automated regression test drops from weeks to mere hours.
And that speed translates directly into faster product releases for the company, which means faster revenue.
And that efficiency is translating into very real career mobility, isn't it?
Yeah.
The metrics coming out of the Indian IT sector, for example, are highly indicative of global trends here.
Oh, for sure.
An entry-level Tosca engineer with less than a year of experience is seeing packages around 4 to 6 lakhs per annum. But because the tool is so heavily adopted at the enterprise level, the ceiling is incredibly high.
Right. An automation architect with maybe 5 years of experience, someone who is designing these overarching modular frameworks, they can command anywhere from 22 to 35 lakhs per annum.
That's incredible growth.
Yeah.
And the most profound takeaway here, I think, is who is actually filling these roles. Because Tosca entirely removes the programming language barrier. It basically shatters the traditional gatekeeping of the IT industry.
It really does. You no longer need a 4-year computer science degree to be an automation engineer.
Right. People from totally non-IT backgrounds,
Right.
arts, commerce, pure sciences, they are successfully transitioning into these lucrative tech roles. Because if you understand the logical flow of how software should work, you can master the tool's modular architecture in a matter of months.
It is a remarkable democratization of software engineering. We've really watched a rapid evolution in this space over the last decade.
Yeah.
We went from humans manually clicking buttons and logging bugs on spreadsheets to humans writing thousands of lines of Java just to click those buttons, to humans architecting visual models to interact directly with the DOM.
Which begs a really, really fascinating question about where we go next. I mean, if we recap the journey today, we looked at the sheer panic of an app crashing and how companies deploy the SDLC and the STLC to catch those critical failures early.
Right.
We saw how the bottleneck of manual testing forced the industry toward automation and how traditional code-heavy automation basically created its own bottleneck.
The dishwasher problem.
Yeah, exactly. And that paved the way for Tosca's model-based test automation. Using Commander to map the DOM with modules, separating the technical locators from the test case recipes, and utilizing tools like property filtering and the X method to bypass the chaos of the UI entirely.
It is a highly optimized system, but as tools like Tosca increasingly remove the need to write code, and as we see newer versions integrating advanced AI that can, dynamically heal broken modules or even predict where a bug might occur based on historical code commits.
Which gets kind of scary.
It does, because what is the future role of the human being in this loop?
Right. If the machine is doing the checking and the machine is writing the tests, does the human tester become obsolete?
I don't think they become obsolete. I actually think the role elevates. They stop being software checkers entirely. I think their real job in the future will be to become, essentially, software psychologists.
Software psychologists.
Or chaos engineers. Professionals whose sole purpose is to understand human irrationality, because the AI can perfectly check if the code functions properly when used correctly. The human's job will be to dream up the unpredictable, highly emotional, completely illogical ways a human being might try to break a system and then force the AI to account for it.
A software psychologist. I absolutely love that framing. Just thinking of all the weird, totally irrational things a panicked, hungry person might do to a food delivery app when their order is 30 minutes late.
Mashing the buttons, swiping randomly.
Exactly. The machine ensures the tracks are laid correctly, but the human ensures the train survives the passenger.
Perfectly said.
So, next time your app crashes while you're trying to order dinner, just remember, somewhere out there, A tester is probably architecting a new modular framework to inject a fix directly into the DOM, making sure it never happens to you again. Keep exploring the architecture around you, and we'll catch you on the next deep dive.